Alright, in this video I'm just going to practice with you a little bit on using your rules for solving series circuits and parallel circuits. So remember your Ohm's law for this. We're going to write it over here so we don't forget. Remember, Ohm's law is volts is equal to amps times ohms. Volts divided by amps gives me ohms. Volts divided by ohms gives me amps. Amps times ohms gives me volts. Okay, so let's look at our series circuit and see if we can figure this out. So our voltage is 12 volts. Our first question asks, what is my total resistance? According to our rules, we know that total resistance is equal to resistance 1 plus resistance 2 plus however many resistances there are. So we have 4 here. 1 plus 2 plus 3 plus 6 equals 12 ohms. Okay, total amperage or total current, same thing. We would take 12 divided by 12 using our Ohm's law, and we would come up with 1 amp. And then according to our rules, we know that in a series circuit, amperage is the same everywhere in the circuit. So when it says, what is the amperage for bulb 1? It's 1 amp. What is it for bulb 2? 1 amp. 1 amp. 1 amp. Okay, now what is the voltage drop for bulb number 1? So if we know that 1 amp went through that bulb, and we isolate it and discuss just what's going on here, or in other words, we apply Ohm's law to just this bulb, if we know our amps and our ohms, that's a multiplication problem. So 1 times 1 is 1 volt dropped. Bulb 2, we also know 1 amp went through it, so we're going to isolate it. 2 times 1, 2 volts. 1 amp went through bulb 3, isolate it. 3 times 1, and our last one, 1 amp went through it. 6 times 1, 6 volts. And then according to our rules, all the volts should be lost by the time we get to the end. So 1 plus 2 plus 3 plus 6 is 12 volts. So we used it all up. Okay, now in a parallel circuit, same thing, 12 volts, 2 different paths for current. So we cannot solve for total resistance yet, because total resistance is equal to total volts divided by total amps, and we don't know our total amps yet. So we're going to find that first. But we can't find our total amps until we find out how many amps are on each branch, because according to our rules, total amperage is equal to amps at branch 1 plus amps at branch 2 plus however many branches there are. So we're actually going to start with this question. What are the amps on branch 1? Well, our rules state that 12 volts or source voltage goes to each branch. So now that I write that there, we can treat this like a series circuit. 12 divided by 4 gives me 3 amps, which is the answer here. On the bottom, that's another series circuit, but this time we have 2 bulbs, so we have to add them together for our resistance on this branch. So it's 12 divided by 4, and we get 3 amps. So how many amps went through bulb 2? 3 amps. And since it's a series circuit over here, the amps is the same. So 3 amps go through both of those bulbs. Now we can answer what my total amperage is. Okay, we know what the amperage on this branch was. It's 3 amps. This branch, 3 amps. So add branch plus branch and we get 6 amps. And now we can find total resistance. Total resistance is equal to total voltage divided by total amperage. So 12 divided by 6 is 2 ohms. Now can we use our verification rule? Yes. Is 2 ohms less than 4 ohms? Yes, it is. Okay. Now how many volts drop on bulb number 1? Well, here's the 2 things we know about bulb number 1. That's a multiplication problem. 3 times 4. 12 volts drop there. Here's what we know about bulb 2. 2 times 3, 6 volts. Again, 2 times 3, 6 volts. So that is how you solve series and parallel circuits using Ohm's law.